Take a look around you. Seriously, the device you're watching this on, the chair you're sitting in, maybe the car in your driveway, they all share a secret origin. They were all born in this hidden world of incredible precision, a world that, well, builds pretty much everything. Just look at this part. You see the complex angles, the perfectly placed holes. It looks like something from a Formula One car or a satellite, right? But the thing is, the phone in your pocket, the tools in your garage, they simply wouldn't exist without the very same technology that creates components just like this. So that's the big question, isn't it? How in the world do you go from just a raw block of metal to something so perfect? It's not magic, but honestly, it's pretty close. It's like a kind of technological alchemy. Well, the answer is something called machine tools. You can think of them as the master machines. They're the machines that make all the other machines, and their story, in a lot of ways, is the story of human civilization itself, stretching all the way back to the Stone Age. So let's actually trace that journey. We're going to go way back to the beginning, just to see how we got from, hitting rocks together to actually harnessing the power of steam. This chart, it really lays it all out for us. You can see on the far left, that's the Stone Age. We're talking basic, almost brutal tools for chopping and scraping. And as we move through the Bronze and Iron Ages, things get more refined, sure, but the real quantum leap, that happens all the way on the right, with the dawn of the Machine Age. Let's break that down for a second. For literally tens of thousands of years, progress was just incredibly slow. Then we get metal, which was a huge step up. But even then, for centuries, everything was still painstakingly made by hand. The real game changer was the boring machine, a tool that could create a truly precise, perfect cylinder. Now, why was that so important? Think about it. A steam engine only works if the piston forms a super tight seal with the cylinder. Without that precision, all that powerful steam just leaks out, and you've got nothing. That one invention made James Watt's steam engine possible in 1776, and bam, the Industrial Revolution was suddenly off to the races. Okay, so that revolution basically created the modern machine shop. Let's take a quick tour and meet the classic machines that are still the foundation of manufacturing today. First up, the drill press. In a lot of ways, this is the direct descendant of the very first mechanical tools. Its job is simple, but it's absolutely fundamental. It makes really, really precise holes. The whole point here is precision. Anybody can poke a hole in something, but a drill press makes sure that hole is perfectly round, perfectly straight, and exactly where you need it to be every single time. And that level of control is the basis for everything from assembling furniture to building jet engines. Next up, we have the engine lathe. This machine uses a completely different way to shape things. And honestly, if you've ever seen a potter's wheel in action, you already get the basic idea. So the key difference between a lathe and, say, a drill press is what's actually moving. On a lathe, the piece of metal, we call it the workpiece, it's the thing that spins really, really fast. The cutting tool is then brought up against it to shave off material. This is how you make any kind of cylindrical part, from a simple drive shaft to the threads on a screw. Now, for about 200 years, those basic machines got better and better, but they were always controlled by a skilled human hand turning a wheel. And then, in the middle of the 20th century, computers showed up and turned everything on its head. Just look at the difference here. On the left, that's a classic manual milling machine. A skilled operator has to carefully turn each of those hand wheels to guide the cutter. But on the right, that's a modern CNC machining center. Here, the operator loads the part, hits go, and a computer program takes over, making incredibly complex moves way faster and more accurately than any human possibly could. This is Computer Numerical Control, or what everyone just calls CNC. The best way to think about it is not as a new machine, but as a brain that you can connect to any machine. It's basically a set of digital instructions that allows for a level of speed, complexity, and, this is the big one, repeatability that was just unimaginable before. In this quote right here, it just nails why CNC was such a revolution. Before CNC, every part was just a little bit different, depending on the skill of the person who made it. After CNC, you could make 10 parts, 1,000, 1,000,000, and they would all be absolutely perfectly identical. Mass production was officially perfected. So, CNC really set the stage for the manufacturing revolution that's happening right now. let's take a quick peek inside the factory of the not-so-distant future. Meet additive manufacturing. You probably know it as 3D printing, and this technology completely flips the script on how things are made. I mean, for all of human history, we made things by taking a block of something and just carving away what we didn't want. This visual really breaks it down. On the left, you've got the traditional way, subtractive manufacturing. It's like a sculptor starting with a block of marble and chipping away. But on the right, that's additive. It's more like building something with Legos, adding material layer by layer, starting from nothing. This lets you create these incredibly complex shapes with almost zero waste. And the innovation is just accelerating. We're now seeing several new revolutions happen all at once. You've got nanotechnology, where we're literally building things from the atom up. There's Industry 4.0, which is creating smart factories where every machine is talking to every other machine. And of course, you have advanced robotics taking on super complex tasks. The factory of the future is really a fusion of all these things.
Okay, so with all this talk about automation, smart factories, and robots, it's pretty easy to wonder, where do people fit into all of this?
Well, here's the answer. Technology doesn't replace human skill, it amplifies it. Behind every single automated program, every complex machine setup, and every single one of these innovations, there is a person with the knowledge, the creativity, and the judgment to make it all work. And this leads us to maybe the most vital takeaway of all. As the machines get smarter, the people who work with them have to evolve too. The skills are shifting, right? From turning a hand wheel to writing code, from manual labor to managing complex systems. The real key to the future isn't just the tech itself, it's our own commitment to continuous, lifelong learning. Which leaves us with a pretty fascinating final thought. We've gone from sharpening rocks to building things atom by atom. We've created machines that can execute our wildest designs with flawless precision. So as these incredible tools become less like tools and more like our partners in creation, you just have to wonder, what will we build next?